Okay, now we're going to fill out our properties of real numbers foldable. It's going to look something like this. It's going to go in section 2.3. Should have 2 pages for it. So we're going to go ahead and fold it all up and cut it up, and then we'll fill it out. Okay, now that we've got our book all put together, we're going to go through and fill it out. And the reason why these properties are so important is because we use them when we do proofs. And the next thing after this part of the notes is talking about different kinds of proofs and what they are. But these are properties that you've learned for a couple of years now. But we're just going to go ahead and put them in this little book so you have them handy just so you can remember. So the first property is the addition property of equality. And the addition property of equality states if A, B, and C are real numbers and A equals B, then A plus C equals B plus C. So since A and B are equal, and if we add the same amount to both of those, they will stay equal. And so over here you see how it relates to angles and to segments, which is really important in geometry. So in angles, if the measure of angle 1 equals the measure of angle 2, then the measure of angle 1 plus the measure of angle 3 equals the measure of angle 2 plus the measure of angle 3. So again, we're just adding the same amount to both of those. And then with segments, it's also very similar. We're adding the same amount to both of these that are already equivalent. Our next property is the subtraction property of equality. Same as addition, only difference is we're subtracting. So if A, B, and C are real numbers and A equals B, then A minus C equals B minus C. And it's going to be similar in the way it relates to angles and also segments. So again, we have our 2 angles that are equivalent, and we're subtracting the same amount from them, so they will stay equivalent. Same thing with segments. Next, we get to the reflexive property, and the reflexive property is one of those, I call it the duh property, because it just, it feels like we shouldn't have to state it. However, there are instances in geometry where when we do proofs, we do have to use the reflexive property. So the reflexive property states if A is a real number, then A equals A. And that's what I mean by the duh property. Of course, A equals A. It's the exact same thing. So when it comes to angles, the measure of angle 1 is the same as the measure of angle 1. Really, in geometry, it has to do with segments. What we're using it for is segments, particularly when we have figures that would share the same side. So that is when we're really going to use this property a lot in our proofs. The substitution property, you should have learned a lot about this in algebra, how to substitute different things. The definition, if A and B are real numbers and A equals B, then A can be substituted in for B. And we see this in angles. So since they're both 56, that means that they're equal to each other. So instead of 56, I just substituted the measure of angle 2 in right here, and I got this right here. Similar with our segments, of course. And the transitive property. So the transitive property is a little confusing. People, usually if they're going to mess up on a property, this is the one they do. If A, B, and C are real numbers, and A equals B, and B equals C, then A equals C. Basically, these 2 are equivalent, and these 2 are equivalent, so that means these 2 outside ones have to be equivalent. And here's what it looks like when we deal with angles, and then when we deal with segments.